The first thing we see here are the sum and difference equations. And so you are going to look at the angle that they've given you. You are going to try to figure out if you have two angles on the unit circle that are known that you can use to add up. So for this one, I would use the cosine of 60 degrees plus 45 degrees, but you can use any two angles that add or subtract to get that. Once you've set up your two angles, you need to use the sum or difference identity to solve for it. So this first one, I would say the cosine of 60 times the cosine of 45 minus, remember it is opposite for cosine, sine of 60, sine of 45 degrees. And then you're just going to plug in what those values are. The cosine of 60 is 1/2. The cosine of 45 is square root of 2 over 2. The sine of 60 is square root of 3 over 2. And the sine of 45 is square root of 2 over 2. And then just simplify it. 1 times the square root of 2, square root of 3 times the square root of 2, all over your common denominator of 4. If you have something in radians, you're going to do exactly the same thing. Just look at your numerators. So this would be like 4 pi over 12 plus 3 pi over 12. And they don't look like unit circle angles, but they are. If you reduce them, you're going to get pi over 3 and pi over 4. And then you're going to do exactly the same thing using your sine formula. Sine of the first one, cosine of the second one, plus cosine of the first one, sine of the second one. And again, fill it in for the actual answers for those trig functions and then simplify. Just a quick note, if you are not comfortable with your radians, you can use your formula to convert it. 7 pi over 12 times 180 over pi. And you can get your angle in degrees and do it the same way you did it for the first one. For this third type of problem, they are just trying to see if you recognize the sum and difference. So I have cosine, cosine, plus sine, sine. This is the formula for a cosine of two angles that are being subtracted. This being my A angle, this being my B angle. So I can just plug those in. The cosine of my first angle minus my second angle. Get a common denominator here, which is 36. So that's the cosine of 50 pi over 36 minus 23 pi over 36. At this point, we're just simplifying. That's the cosine of 27 pi over 36, which reduces, of course, to the cosine of 3 pi over 4. This is a known angle on the unit circle. 3 pi over 4 is one of your 45-degree angles in the second quadrant. The cosine of a 45-degree angle is square root of 2 over 2, and in the second quadrant, it is negative. This is also just wanting you to recognize which formula they're using. So if you have the sine cosine plus the cosine sine, that represents the sine of the first angle plus the second angle. This one being your first angle, this one being your second angle. So you can replace all of this with that. And you can just say the sine of the first one plus the second one, which gives you the sine of just one u, and you are done. For these, you're going to use either the double angle or the half angle. Obviously, if they have 2 times theta, you're going to use double angle. Theta over 2, you're going to use half angle. You do need to know where theta is located. This is quadrant 1. So this helps you know what signs, positive and negative, to use. If you are finding tangent, you do need to have to find the cosine. So you can use a couple of methods. You can say the Pythagorean identity, sine squared plus cosine squared equals 1. You can use SOHCAHTOA, sine of theta is opposite over hypotenuse. So you can use Pythagorean theorem to solve for adjacent. However you do this, you will get that the cosine of theta equals 8 over 17. Once you solve for cosine, you need to establish what tangent is. The tangent is going to be the sine over the cosine. So your tangent is going to be 15 over 8. And once you do that, the double angle of tangent, you are now just plugging in that formula for double angle. So double angle of tangent is 2 times tangent of theta over 1 minus tangent squared of theta. So you're going to take this tangent and plug it in. So 2 times 15 over 8 minus over 1 minus 15 over 8 squared. At this point, you're just really reducing it and simplifying it. 2 times 15 over 8 is 15 over 4. This part is 1 minus 225 over 64. So when you get a common denominator, you end up with 15 over 4 over negative 161 over 64. You're going to keep change flip, so you have 15 over 4 times, flip the bottom 164 over 161. 4 and 64 reduce, multiply across. You will get negative 240 over 161, and you are finished. For this one, all of your half angles use cosine. So they've given you sine, you must find cosine. And again, you can use your Pythagorean identities or SOHCAHTOA here to solve that cosine is 3 over 5. Once again, it is in the first quadrant, so you know that the cosine is positive. And then you are just plugging it into your half angle for your half angle identity for sine. And that, remember, is positive or negative 1 minus the cosine of theta over 2. Because we've determined that we're in the first quadrant and we are just cutting that in half, then you know this guy is also going to be the first quadrant. So your answer here is going to be positive. So we're just going to plug this in. The square root then of 1 minus 3/5 over 2. Get a common, so you get 5/5 minus 3/5 over 2. Simplify it. 2/5 over 2, which is going to give you just 1/5. We are taking the square root of 1/5. We've already decided we're only using the positive root. So we have the square root of 1 over the square root of 5. Simplify that. Rationalize your denominator, and you will get square root of 5 over 5. For this one, we do need to find out what quadrant we're in. So if I look at 7 pi over 12, this guy is 6 pi over 12. So 7 pi over 12 is going to be my second quadrant, which means my cosine is going to be negative. It's telling me to use half angle. So half angle means that I need some angle over 2 that equals 7 pi over 12. The way to find that is just to multiply 7 pi over 12 by 2. And you will get 7 pi over 6. So we can say that 7 pi over 12 is the same thing as 7 pi over 6 over 2. So that means we can rewrite the cosine of 7 pi over 12 as the cosine of 7 pi over 6 over 2. That helps us because 7 pi over 6 is on the unit circle, and we have a formula for the cosine of some angle over 2. That is going to equal the 1 plus cosine of theta over 2. Obviously, positive or negative, we've determined that we are in the second quadrant, so we know this guy is going to be negative. And we're just going to fill it in. So negative square root of 1 plus theta here is 7 pi over 6. So cosine of 7 pi over 6 over 2. The cosine of 7 pi over 6 is negative square root of 3 over 2, because that one is in the third quadrant. So we have 1 minus the square root of 3 over 2, all over 2. We're going to simplify this. Get a common denominator, 2 over 2 minus the square root of 3 over 2, all over 2. That simplifies to 2 minus the square root of 3 over 4. Obviously, the top does not have a perfect root. The bottom does. So we are finished. We're going to do exactly the same thing here. If we need to know how to set this up, we could say, well, the cosine of 15 is the same thing as the cosine of 30 over 2. And we can do the same process with our half angle formula using 30. And go from there and just plug it in. So determine what quadrant you're in. Determine what angle you need to use. That is, if we cut it in half, it equals this angle. And then just use your half angle formula. The last page is solving equations. So when you're solving equations, you're going to use either your double or your half angle here. You notice that we have a theta, a 2 theta, a theta, and a theta. So this guy has to be rewritten so that it is just a theta. So we are going to replace that with our double angle. So the double angle here is 2 times the sine of theta cosine of theta. Bring this down, square root of 2 cosine of theta. And of course, if we have the same thing on both sides, when you subtract it over, those just cancel. So you end up with that equals 0. At this point, we can factor out that cosine that they have in common. You are left with the square root of 2 plus 2 times the sine of theta equals 0. Set each piece equal to 0, so the cosine of theta equals 0. Square root of 2 plus 2 sine of theta equals 0. And then just solve on the unit circle. What angle gives me a cosine of 0? Well, that's 2 angles. It's pi over 2 and 3 pi over 2. If I were to solve this, I am looking for where the sine of theta, subtract your square root of 2 over, divide by 2. So what angle gives me a negative square root of 2 over 2 for sine? Well, that's my pi over 4s in the third and fourth quadrant. So that is my 5 pi over 4 and my 7 pi over 4. Once again, for this problem, you can see that you have a theta and a theta over 2. So I do need to replace this theta over 2 with my half angle identity. And so I'm going to rewrite this 1 minus the cosine of theta equals 2. And the half angle here is the positive or negative root of 1 minus the cosine of theta over 2. To get rid of my radical, I am going to square both sides. Don't forget that you do have to FOIL here. You do have to consider that you are multiplying it through, not just squaring the first and the second. So when you FOIL here, you get 1 minus 2 cosine of theta plus the cosine squared of theta. On the right-hand side, when you square this, that positive and negative goes away because whether you square a positive or square a negative, it's going to be positive. So I do have to square the 2, so that gives me a 4. When I square this piece of it, I just get rid of that radical. You can simplify it. The 2 and the 4 reduce. And so I'm left with 1 minus 2 times the cosine of theta plus the cosine squared of theta equals, and I'm going to distribute that 2 through, 2 minus 2 cosine of theta. Once again, you can see you have a negative 2 cosine of theta and a negative 2 cosine of theta. So those will cancel each other out when they're on opposite sides of the equation, which means I can just subtract my 1 over. On this side, I am left with the cosine squared of theta. 2 minus 1 is 1. I do need to take the square root of both sides. Remember, when you take the square root, you have to consider the positive and negative root. So the cosine of theta is going to equal positive or negative 1. On my unit circle, the angle that will give me a positive 1 for cosine is 0, and the angle that will give me a negative 1 for cosine is pi.